Greetings. So today's class in our programming we'll see about the data types and their memory representations. So what is a data type? A data type in embedded C specifies the type of data a variable can store, the amount of memory allocated and the range of values it can represent. And it's very important to choose the correct data type because microcontrollers will have only limited power, memory and power, processing power. You know that microcontrollers are used for all kinds of embedded applications. So the memory optimization and the power optimization is very important. So when you need a location of 8 bits to store a data, but instead you have allocated around 32 bits, 3 additional memory locations going wasted. So that is the main part in data type. You have to choose the data type very carefully. Efficient use of data types reduces memory usage, it improves execution speed and enhances system performance. So when you need to have a very less memory, you can accommodate everything inside very less memory. You are a good embedded engineer. And what is a data type? The data type defines the type of value a variable can store, the amount of memory required, the range of values, the operations that can be performed on the data. So you can see as example what I've given is unsigned char temperature is equal to 35. So from here you can understand the unsigned char, it is a data type and temperature is a variable. So and again, since we have given it char, it occupies only a 1 byte of memory. So looking into the classification of data types, embedded C data types are classified into 4 categories. First one is a basic data type, or otherwise called as a primitive data type. So already we have seen this thing. It means it is char, int, float, double, void. All these are primitive already, which is very famous and very commonly used data types. And derived data types, so what we have seen this as a user defined types in earlier class. Now it's called as a derived data types. So arrays, pointers, functions, all these things, it's derived. So from earlier used data types, this has been derived. So you can say it's int marks and inside bracket 10. So you need to have it to be understood that 10 memory location has to be stored for the marks, for the variable mark, and the data type is int. So the next one is a user defined data types. So as we saw in the last class, you have a structure, you have union, enumeration and type def, and you can see a small example that is given. A structure is given and it's named as student, and what is the name, how much of locations has to be given, and roll number, everything is mentioned. So modify data types, modifiers alter the size or range of a data type. So you can see something is called as a signed, something is called as unsigned, something short, and another one is a long. So when you mean it is unsigned int count, so the value count is mentioned with a type int, and it is mentioned as a unsigned. So the same thing, if you have mentioned it's signed, so now the range may change. And similarly the distance is mentioned as int, and it is mentioned with a data type long int. So memory representation of data types can be seen here in the slide. You can see a character is 1 byte. It takes a value from minus 128 to plus 127. So it means it is signed char. So before going into the signed char, we can look into a unsigned char. So again, unsigned char, it takes only 1 byte of location, and the values will be 2 power 8, that is 0 to 255. And similarly, when you look into the char, it is signed. So the last bit will go for the signed operation. It will be minus 128 to plus 127, and the int value is minus 32768 to plus 32767. And similarly, unsigned is, it takes around 2 bytes because it's all are 16 bits. Int and unsigned, it is 16 bit, so 0 to 65 535. Long int is doubling of the location, So instead of 16 bits you need to have around 32 bits. So minus 2 power 31 to 2 power 31 minus 1. Similarly unsigned 4 bytes, 0 to 2 power 32 minus 1. Float is also takes 4 memory location, so it is 4 bytes plus or minus 3.4 into 10 to the power of 38. Double, it's compiler dependent, and the void is just again a null value, so you don't have any storage or value there. Thank you.